Hello, Mr. Andy here. It is week 4, excuse me, and we're going to look at some new tools this week, of course. And in our first part, you can see if you look at this part, we'll click on this, that it's kind of tiny, but we have lots of different style holes on this part. Very simple shape, just an ellipse, and a whole variety of holes here. So we're going to take a look at Hole Wizard today. Please read the note here. It says, no pre-sketching of Hole Wizard locations. Location dimensions and reference geometry must be created inside Hole Wizard. So do not create any sketches with construction lines or anything and close them, and then go into Hole Wizard and reference that geometry. It's not what the folks that we meet with that use SolidWorks want us to do. They want all that geometry inside Hole Wizard. So I want you to be very careful not to sketch something, close that sketch, and then start into Hole Wizard and be dimensioning or using that geometry from a previous sketch. Okay? All right. So this is the part, and I'm not going to obviously do all these holes. I'm just going to do a couple sets of holes here just so you can get the idea of what's going on. So let's click into our drawing. There are a couple ways you can use Hole Wizard. My recommendation to you is to click on the surface that you want to put the hole on first to kind of prevent the chance of getting a 3D sketch. We'd prefer not to do that in most situations. So I'm going to click on this surface to light it up, and then I'm going to go up here and click on Hole Wizard. Now, Hole Wizard is pretty slick if you haven't used it before versus what you're used to, say, in AutoCAD, in that all the holes are pre-configured. And you don't have to put the sizes in. You just tell it what size fastener you want to use, and it knows from the machinery handbook data what that hole should look like, what diameter it should be, what size the countersink or counterbore should be, or whatever the case. So there are 6 types of holes here in Hole Wizard. Counter bored hole for a socket head cap screw or maybe a hex head. Counter sunk screw for flathead screws. Plain drilled hole. A tapped hole, threaded hole. This is a pipe tap. We probably won't use that this semester, but we'll use it in Advanced SolidWorks. And then this is a legacy, and that's if you have holes that are not according to standard that your company does, you can set them up here in the legacy and save them to use them. So if you have custom hole sizes that are not to standard, you can do it that way. So your first job, and our first 2 holes we're going to do, if you come over here to the right, are these 2 plain drilled holes. They're a 5/8 by 1 inch deep, right there and right there. So I'm going to click on a drilled hole. The next thing you want to do each time, make sure you're okay, is that you select your unit. Are you an ANSI inch, ANSI metric? Obviously there are lots of other standards here we can use, but we'll be using strictly these 2. Well, this is an inch part, so we're going to stick with ANSI inch. And then you can even choose, for instance, there are lots of different series of inch-size drills, from fractional drills, helical tap drills, letter drill sizes, number drill sizes, etc. We're going to go with fractional drill sizes because it's a 5/8. It just shortens up the list. You can select all, and you'll get this huge list. By selecting fractional, it'll shorten your list up. And as you can see, I had just used this as I was testing things out. So 5/8 is already selected, so I don't have to do that again. You can change the sizing of a hole. So if you click on custom sizing, it gives you all kinds of stuff you can change if you want. Typically, we won't do that. There is an exception to that this semester. We will be doing some custom sizing. But we're going to go blind, and we're going to go 1 inch. And you just put your depth in right here. Then SolidWorks is asking if we want a near side countersink. I'm going to turn that off. It doesn't matter. If you leave it on, that's fine. But we don't need that, so we'll turn that off. All right, so I have my hole set up here. Now I'm going to click on the Positions tab up here. And when you enter the Positions tab, you will notice right here that the point tool is already selected for you. Okay? And basically, anywhere you put a point, SolidWorks is going to put a hole. So I could sit here and drop points. I'll just drop a bunch of them here just for a sec. And I'm going to hit escape. And so anywhere I placed a point, there's a hole. Well, I don't need these holes. So I can just delete those points. So as you're working in this sketch inside Hole Wizard, anywhere you want a hole, use the point tool and just click a point. Of course, then you're going to have to define it. And that will give you a hole. So I've put the 2 holes in. I'm going to go normal 2 here. Now, one of the habits I'd like you to get into is not creating a lot of extra geometry when you don't need to. For instance, some of you might be inclined to draw a center line here across there. I can move that center line and the holes will move with it. And I could relate it to this origin. However, there's really no need to have that piece of geometry in the model. I mean, if you want to do it, it's fine. I just like keeping geometry out of the way if I can. Because really, we can just pick these 3 points and just do a horizontal relation. It's not any more work than putting the line in. And now I'm going to dimension the distance to each hole, which is 3.63. And we're fully defined now. And so I can just hit OK. And SOLIDWORKS is going to produce 2 drilled holes for me. Now the other one I'm going to do here is this little collection of 4 holes on a circular pattern here. They are 3/8 flathead screw holes on a 1.75 bolt circle, and that circle is 1.5 inches below the center of the part. So again, I want to click on this face normally. I'm not going to do that so you can see the difference. Click on this face and then start Hole Wizard, but I'm going to do it the other way. I'm going to just start Hole Wizard so you can see the other way through. And we're going to do a countersunk. For inch drawings, you can assume 82 degrees unless I tell you it's 100 degrees. Kind of standard inch screws are 82. So if you see 100 degrees, and you can see it right here in the handout, it says 82, but it won't always say that. If it doesn't say, pick 82, but I probably wouldn't knock you either way on that one. And it's a 3/8 socket head cap or flathead screw. And then for fit, it doesn't really normal is what we would normally use. Close fits would be for tooling drawings and things, but you don't have to be too concerned with that. If I gave you specific diameters, you could choose the right one by showing custom sizing. It'll tell you what those sizes are. We're going to go through all, and we don't need head clearance or anything like that. So now I'm going to click on positions, and we'll get a little different response here because it says select the face where you want to place a hole, or we can start a 3D sketch. Well, what I don't want you to do is start a 3D sketch for these parts. So I'm going to click on this face. And if you don't get a preview here, then you need to stop and ask for help. Well, I'm not ready to draw points yet. I'm not ready to put the hole locations in because I need some geometry to locate them. So I'm actually going to get out of the point tool. And I'm going to draw, let's go normal 2 here. I'm going to draw a construction line straight down. And then I'm going to draw a circle. And I'm going to turn that into a construction circle. And I'm going to go ahead and dimension those. I'm going to pick the line, and that is going to be 1.5. And then I'm going to pick the circle and get that 1.75 diameter there. Okay? So that's my construction geometry. You can get away with not turning them into center line, construction line, but I want you to do that. I will pick on you if you don't. So don't leave these solid object type lines. I want them to be construction line geometry. Now I'm going to go back to the point tool, and I'm just going to drop a point on each quadrant point of that circle. If I do this right, they should all fully define. And you can see that our sketch is fully defined down here. We can see our previews, and we'll hit OK. And there's our hole pattern. Let me show you what happens underneath a Hole Wizard hole in terms of the feature. So I'm going to expand this, and you can see there are two sketches here. The first sketch is your sketch, your placement sketch, your location sketch, and I can edit that sketch, and it takes me back to this thing. Okay? This sketch has to be fully defined, so that's another sketch you'll need to check to make sure you're fully defined. The second sketch underneath Hole Wizard is SolidWorks profile that it creates to make the hole. And you can see that this hole is actually created as a revolved cut, if you will, internally inside SolidWorks. And so SolidWorks builds a sketch for that hole. And you can actually edit that sketch if you really wanted to. That's what it looks like. But I don't want you to do that. But if you were trying to create a custom hole, you could go right in here and edit this sketch and change the shape of that hole. But don't mess, in this class, don't ever mess with the second sketch. The first sketch, in every case, will be the placement sketch, and the second sketch will be the profile of the hole itself. Okay? All right, well, I'm going to throw this part away. You think you can take it from there? By the way, the only other holes that you'll create geometry for are these two. All the other holes you can just do with the dimension tool. You can dimension off the origin to get these hole locations. You don't need to create any center lines or anything to place any of these other holes except these two. You're going to have to create this 30-degree angle and these 1-inch dimensions and get all that located. So that's the first part. And I'm just going to throw this away. All right. Now, I have already started the second part, and I actually have started it wrong. So I want to show you the picture here. This is your base sketch. Notice the origin is down here. This sketch will be 62 millimeters from here to the nose of the arc. It'll be 65 high, right here actually, 65 high, and when we extrude it, 65 deep. You'll notice I have the origin in the middle in my pictures here. So let's fix that. We're going to change that to a mid-plane extrude. Having the origin in the center actually doesn't affect much for us, but we'll make it look like that picture. So the next step is to shell it out. So we haven't looked at the shell command yet, so I'd kind of like to show you that. And so as we look at this, I'm going to click on the shell command. And this is how the shell command works. If I click on a surface, so I've clicked on this surface now, SolidWorks is going to shell the part out, and it's going to destroy the surface. This surface is going to become an open space. So let's just hit OK. It's at 10 millimeters. Let's hit OK, and you can see what happens. So it maintains a wall thickness everywhere of 10 millimeters, and this surface gets taken out. Okay. Well, let's delete that feature. And let's try another one. Let's do a shell. And let's pick two surfaces and hit OK. And you can see that it took both those surfaces out. This surface is still there because I didn't select it out on this outside face. And again, we still have 10 millimeter wall thickness. And you can set your wall thickness to whatever you want. You can even do variable wall thicknesses on different surfaces. Let's delete that. So your first question is, you ready? Let's do a shell. 10 millimeters. I'm not going to pick any surface. I'm just going to hit enter. So did anything happen? That's the question. Because the model doesn't look any different. I can spin this around and you can see that it's still the same on the outside. But you can see that we do have a shell feature. So if this happens to you and you just accidentally did it, you need to delete this feature because your part is actually now hollow. So if you can see the hidden line geometry in there, we could go to wireframe. It would stand out even better. There is a pocket inside this part, a hollowed out pocket with 10 millimeter wall thickness. Now, this would be a mighty hard part to produce. You could only do this probably in like a rotational mold or something to create this kind of hollow interior core. But don't think just because you didn't see anything happen that nothing happened if you do that. So let's delete that. And we'll go back to our normal display here. Now, we're going to shell this out. So I'm going to click on the shell tool. And we need to take out all these surfaces in here. So I want to take out this surface and this surface and this surface and hit OK. And that takes that out and gives me that look that we're after. You can remember, this is the front view here, and that's the front view. This section is the front view here, so we've got the right look. Now I need this nose on the end, and so I'm going to introduce you now to the plane tool, which is part of our subject for this week, is to work with planes. Now, if you see the part here, let's zoom up a little bit on it. Make sure I'm on screen. When you see this part here, this nose is out here. It's at 75 millimeters. And this would be rather tough to create. You know, I could sketch on the right side plane here. I could draw a circle here and extrude it out, that 75 millimeters, but then I have this big cylinder in here and I'd have to cut it away or something. That's not a very elegant way to do this part, nor do I want you to do it that way. So what we'd really like is to have a plane out here that we could draw a circle on and just extrude it up to this surface. Okay? So that's what we're going to do. So I'm going to turn on, or I'm going to click on the right plane because that's where the 75 is measured from, is right through the center of these two holes, 75 out. That's why we need the origin to be here on this surface. Doesn't really matter where it is from front to back, but it has to be right there. So let's click on the plane tool. This might take a second to load. Nope, it's going to come right up. And the right plane was selected. And you can see there's lots of options, parallel, perpendicular, whatever. We'll use these over the course of the semester, but for right now, we need a distance of 75. And window around, make sure it looks like what you think it should, and that's about right where we think it should be, so we'll hit OK. Okay. Now we have a new plane. It's like any other of the three front, top, right side planes that we get. I'm going to click on this plane and start a sketch, and we'll go normal 2. I want you to be careful. I gave you these 32.5 dimensions here. Do not, like draw some construction lines off midpoints and attach the hole wizard hole there or the circle there. I want to see these dimensions in the model positioning this boss. So I'm going to do a circle just out here somewhere, and then I'm going to dimension that circle 32.5 off the bottom and 32.5 off the side. Boy, I got that one pretty close. So I got it right on because I lined it up with the origin. And it has a diameter of 30 millimeters. Okay, and then we're going to take that circle and we're going to extrude it up to that surface. So we'll just go right to Feature, Extrude. We're going to say up to Next will work. But we'll hit up to Surface and we'll pick that surface. There we go. Wouldn't give me up to Next because it was going the other direction. And there was no Next out there. There it is. That's our hole. If the plane gets in your way, you can just come up here and you can turn off all plane display. You can also click on the plane right here and hide it by clicking on the glasses right there. And that gets it out of the way if you don't want to see it. All right, I do want to do this rather odd hole for you that's through the part, and it has a shallow counterbore. This is not a hole wizard hole. This is a totally custom kind of specialty hole. So there's a trick here I want to show you to keep from adding too many dimensions. So we're going to go normal 2 on this face. I'm going to draw a circle. I'm going to dimension that circle at 40 millimeters. And I'm going to cut that through all. That's the first part of the hole that we want. So Feature, Extruded Cut, through all, and hit OK. So now I have the base hole going through the part. Now up here on top, I'm going to create that little counterbore. So we'll do a second circle. I'll touch the edge to grab the origin or center point. I'll drag that out. I'll do a dimension of 48. And I'm going to cut that 3 millimeters deep. All right, so I have the cut counterbore on the top surface. Obviously, we don't have one on the bottom yet. So we're going to do that next. But we're going to do this in a somewhat unique way. So I want to show you this. We're going to click on this face. We're going to start a sketch. And I'm not going to draw anything. So this is our sketch plane down here. Now, we've used the convert tool, but we haven't used it in this way yet. So this is what I'm going to do. I'm going to click on the convert tool, and I'm going to pick this outside edge of the 48 millimeter counter bore. And what the convert tool really does, and this is where we really come into using the convert tool, is I can click a piece of geometry way somewhere else, and when I convert, it's going to convert that to a circle in this case on my sketch plane. So my sketch plane is down here. So when I click OK, SOLIDWORKS is going to create a circle for me that is that edge, if you will, smashed flat onto this surface. Okay, this only works because these two holes line up. If they were at different angles or something, it wouldn't work. Now I can cut that. Notice there's no dimension now. It's fully defined, no dimension. I only have one 48 millimeter dimension in the part. And I can cut that 3 millimeters. Now, it does put another 3 millimeter dimension in the model, but that's all right. The cool thing about that is, if I change the diameter of this one, if I were to go back and edit this sketch and change this diameter, both of the counter bores would update at the same time. I wouldn't have to edit this one. It'll just automatically follow this edge that was created here when the cut was done. So anyways, then you'll hole wizard hole here, and I think you have a fillet to do, and you're good to go. All right, one more part in this first video. So let's take a look here. On this part, I'll drag this on screen a little bit more. You can see it's 2.5 inches deep in the top view. It's 4 inches across in the front view. What's a little hard to see is that these lines here aren't vertical. They are at an angle. And this part has draft angles of 4 degrees on all the features. This is going to be a molded part. And so to get it out of the mold, we have to have draft angles on all of our vertical features to facilitate it coming out of the mold. So the first thing to note, again, this is the front, top, right side view. First thing to note is that the 4 inches is the top edge of the part, the top surface, not the bottom. So you need to be very careful when you extrude this with the draft angle that you don't make the part bigger. It's got to get smaller as it gets extruded by 2.5. Then it's hollowed out. I think you can see that in the section view. It's kind of hollowed out. And then there are these 4 bosses sticking up. You can see them in the isometric view up here. These bosses sticking up. And then there's a rib in here, and we're going to look at the rib tool today too also. Okay. Let's click into drawing space. It's a pretty simple part. I'm going to slide this way over. You're only seeing this part of the view now, but that's all right. And we're going to start a new file. This is an inch part. So on the top plane, I'm going to start a sketch and draw a rectangle. And then we'll dimension that rectangle 4 inches by 2.5. Don't really care where the origin is on this part. Now I'm ready to extrude that. Now I'm going to look at this view. Remember we said if we extrude up, that's a little farther than I wanted to go, 0.75. If we extrude up, when I turn that draft angle on, which is that button right there, and set it at 4 degrees, that's not the shape we want, right? The top surface is going to be the bigger surface. So I have to go the opposite direction here. So I need you to be very careful when you create this part. You've got to extrude it down so that it gets narrower as it's going down, like you see in the front view here. The top is 4 inches. The bottom, we don't know. Also notice I didn't put the fillets in here. I didn't put these sketch fillets in, and there's a reason for that. Let's click OK. I'm going to put them in as normal fillets now. And the reason I didn't put them in as sketch fillets is the draft angle would have caused that filleted corner to taper. And we don't want that. So this will be a constant 1/2 inch radius if I do it this way. So let's get the right size here. And we'll pick these 4 corners. And notice I picked right through the model there. It's a nice trick that you can use. And we'll hit OK. And then there's a 1/4 inch fillet down here all the way around the bottom of the part. So I'm going to go right back to the fillet tool, 0.25, and I'm going to pick that bottom edge and put that fillet all the way around. All right, now I'm ready to shell. You cannot shell until you've done the fillets, because notice, if you can see it in the drawing here, the interior line follows the fillet, right? Follows that contour. There's no way to get that in after the fact. So we're going to click on that surface and do a shell, and the wall thickness is 0.12. There's our shelled out part. Now, these bosses, when you create them, there's no dimension to locate them, so the assumption, and again I did this intentionally, but the assumption is they have to be concentric to these outside curves. It's the only way we can place them. But they are, if I drag this over real quick, they are 1/8 of an inch below the top surface, okay? And we don't know the diameter at the base, so we can't draw them on the floor and extrude them up with a draft angle. They're a 1/4 inch diameter up here. So I'm going to have to create a circle right here and dimension it. So I need a plane 1/8 of an inch down. I also, while I'm there, I need another plane 1/8 of an inch below that for the top of the rib. So I'm going to create those two planes first, and I'll leave the drawing just like that. We'll slide over just a little bit more. So I need a plane 1/8 of an inch below the top surface. So I'm going to click on the top surface and hit the plane tool. And it's way off in space there. We're going to go 0.12, and we can see that it went the wrong direction. So you want to get into a view where you can tell what direction you're going. So we're going to flip that plane, and we're going to hit check. And then while that plane is lit up, I'm going to hit plane tool again, and it's going to give me a parallel plane to the plane that was highlighted. Again, 0.12 millimeters. And we'll hit OK. Now I have two planes. Don't do any math. Don't put that second plane at 240 down from the top. All right. So let's do the bosses first. I'm going to click on the top plane and start a sketch. I'm only going to do a couple of them. We'll go normal 2. Now I'll show you kind of a fault in SolidWorks, if you will. I'm going to touch this outside circle and drop that right there. And I'll touch this outside circle and drop that one right there. I'm going to dimension one of them at 0.25. I'm going to equal relate them. Like so. And notice they're underdefined. Well, in spite of the fact that we dropped them on those centers, I think it's because we're on a custom plane below the surface where that arc is. It does not create the relationship, even though it looked like it was going to. So you don't need to bother to do the center points, because you're going to have to manually relate them. So I'm going to click on that circle, click on that arc, make them concentric, click on that circle, click on that arc, make them concentric. You're going to have to do that for all 4 holes. I'm not going to do the other 2. I'm just going to go ahead and extrude these really quick. Again, we want to go other direction, up to next. And we're going to do a draft angle of 4 degrees, and you can see that's not what we want. We need to go outward with that draft angle, and we'll hit OK. All right, finally, in this video, we're going to look at the rib tool. The rib tool is pretty slick, and I'm going to click on the bottom of those 2 planes and start a sketch. And let's go normal 2 here. And let's just play for a second. I'm going to just draw a line right here. Totally underdefined. And let's go to the rib tool. I want you to see what the rib tool does. Now, by default, the rib tool wants to extrude that rib, can you see it? Parallel to the plane, the sketch plane. And that's not what we want. We want this rib to go down. So there's 2 buttons here. You can go parallel to the sketch plane, or you can go perpendicular to the sketch plane. This is the button that we want. We're going to go perpendicular to the sketch plane. That's the only way you can do this particular set of ribs. And then you have to decide how the thickness will be created. All in one direction, mid-plane, or all in the other direction. We want mid-plane, and it's 0.12 for the thickness. And now watch this. I'm just going to hit OK, and then we'll talk about what happened. So what the rib tool does, it takes that line and extends it in 3 directions, to the left, to the right, and down, in the direction that that arrow was pointing, until it hits something. If you have an open-ended part on one end, you cannot use the rib tool. It won't work because it would just be going till infinity, and that doesn't work. So you have to make sure that you have that done. Now I'm going to edit this sketch just for the fun of it. And let's do this. Let's draw a circle right here. Okay. And let's just close the sketch, and you can see what we would get from the rib tool. Notice that the circle terminated this edge. Okay. If I needed that rib to keep going, if I pulled this through to the other side, then it would keep going. So that's the kind of stuff we can get from the rib tool. All right, so let's edit this sketch. I'm going to delete these, and let's do it the right way. So let's go normal 2. Again, there's no placement information for these ribs, so we're going to assume they're just centered on the part. So I'm going to have to attach to the midpoint there. And all you have to do is go past center. This is your maybe your only chance this semester to give me an underdefined sketch. So as long as the line is black, which means it's positioned vertically or horizontally, as long as the line is black, even though these endpoints are blue and the sketch is underdefined, as long as they cross, you're perfectly fine. You can just hit OK. Now there's one problem with this rib, and that's that we didn't draft it. So let's edit this feature. And let's turn on the draft angle at 4 degrees. And we want to draft outward, and we'll hit OK. And now we should see that draft angle. Okay, you can see the rib getting wider. Now you're just left to fillet things up, and you'll be good to go. Notice that like all the corners on the interior, except the tops of those bosses, all these inside corners on the ribs and on the bottom of the boss, those are all filleted. So make sure you get all those filleted. And then finally, you've got some hole wizard holes to do. And those are going to require a kind of a custom set because they're at a depth of 1/2 inch. Normally a countersunk hole is through, so you're going to have to change the depth to 1/2 inch. Okay? All right, good luck. This will be another video for the second part of this week. And as always, enjoy.